Hi guys. This is my 5th time of doing this, okay? Because I forgot to hit the screen recording. All right. So anyway, I've already shown you the ruler drop thing. Hopefully that was working. Now let's look at those slides again. Let's look at these slides. Now this is kind of scary. Now we saw, here we go. An object is in free fall at 9.8 meters per second squared, okay? Here on Earth. Now up on the moon it's different, deep dark space, there's no acceleration on anything, but here on Earth it's 9.8 meters per second squared. All right? And if I drop two objects at the same time, they're going to hit at the same time. You saw that in those misconceptions of free fall. Some people think, oh, the heavier objects. Now, it boils down to which one would you rather have hit you, the heavier object or the lighter object, because it's got more force coming down. Okay. Because it needs a lot more inertia, right? So but the accelerations are the same. All right, so now here are the constant acceleration equations for free fall, and let's talk about what we mean by acceleration. All right, let's just talk about acceleration here real quick. Okay, here's what we mean by acceleration. And I've written these things down, and I'll provide these notes. I usually like to write these down as you're following along, but I wrote them all down and was lecturing on this stuff, but I'd forgot to turn on the recorder. So nothing was getting recorded. So here's a note. So what is acceleration? Well, it's the change in velocity or the change in time. Okay, so if I go from 0 to 60 miles per hour in 10 seconds, then my acceleration is 60 minus 0 divided by 10, which is 6 miles per hour per second. Okay, then I have my velocity equals the initial velocity plus, and so we're going to be dealing with, but we're going to be dealing in meters per second squared. So notice this is a miles per hour, so that's actually a divided sign. So we've got hour seconds here, which are kind of funny time unit, but it's okay. In other words, what's happening here is for every 6 seconds, every second, the car is gaining 6 miles per hour in speed. Now its distance is creating exponentially in a square, in a parabola type graph, okay, because of the time squared thing. See, because to get rid of this, to just make this meters, I have to multiply it by a time squared. So it's really gaining a lot of ground when things are accelerating. All right, so we're going to look at we're going to change the minuses to plus because we're just dealing with speeds. I'm not going to play the vector game with you. So the initial velocity so the final velocity of something is equal to its initial velocity plus gravity times time. So if we've got 0 meters per second and something falls for 3 seconds, the velocity is going to equal, okay, well, let's figure this out. Well, if v is equal to 0, plus 9.3 times 3, that'll be 29.4 meters per second when you multiply that out. Y final is equal to y plus v naught y plus 1/2 gt squared. V naught is equal to t minus 2 seconds. Okay, so v is equal to 0 and t is equal to 2 seconds. And so I just plug these numbers in to find out how far something fell. In other words, what we're doing here, how far did it fall in 2 seconds? Well, if I just drop it, it starts, this is 0 because we're just counting that as the initial height is 0. Initial distance is 0. And then the initial velocity, if I just drop it, is 0 here. And then it's 1/2 9.8 times 2 squared. When I do that calculation, I get 19.6 meters. Okay? Those are the general equations that we're going to be doing with this thing. All right? With this pre-lab. All right. Seems like it's going to be harder than it is, but it's not going to be that